Hello everyone, welcome to Ustream that is supported by IEEE Photonics Society. My name is Hamed Majedi. I'm the primary guest editor of the special issue on superconducting, quantum electronics and photonics that is going to be featured in Journal of Selected Topics in Quantum Electronics. We are going to actually answer your questions, but before doing that, I would like to highlight about this special issue. This special issue is going to document the state of the art and progress in superconducting quantum electronics, superconducting photonics and optoelectronic devices. And we are going to focus from all aspects of this technology, from physics to materials, modeling and experimental characterization, and system integration. So we would like to highlight the importance of superconducting structures in the quantum technological platforms that is going to be used in computation, communication, metrology, sensing and imaging. And we are going to have a call on two different parts. First of all, we're going to have on superconducting quantum electronics. The primary focus is going to be on 5 subjects. And as you can see in the call, we're going to focus on quantum information devices and circuits, circuit cavity, quantum electrodynamics, and microwave quantum optics, novel Josephson junctions and squid devices, structures and circuits, also novel electromagnetic structures, including metamaterials and photonic band gap structures, as well as the hybrid superconducting quantum circuits and systems. On the superconducting quantum photonics part, we are going to focus on single and entangled photon sources based on superconducting structures, single photon detectors, and quantum optoelectronics using the hybrid superconductor semiconductor structures. So the primary guest editor is me, Hamed Majedi, from University of Waterloo, and in this special issue, 4 great scientists are going to help me. Guest editors are Kathy Foley from CSIRO from Australia, Yasunobu Nakamura from University of Tokyo in Japan, William Oliver from MIT Lincoln Laboratory in United States of America, and Sergio Pagano from University of Salerno in Italy. So I don't see any questions coming down the pipe, so I'm going to talk about a little bit myself. So I have done my Bachelor of Science in Electrical Engineering with major in Telecommunication Engineering in Haji Nasir Tusi University of Technology in Tehran, Iran in 1994. And I obtained my master degree again in Electrical Engineering with a focus on fields and waves and photonics from Amir Kabir University of Technology, again in Tehran, Iran. And after that I came to Canada to do my PhD in 1998. So I got my PhD at the University of Waterloo in 2001 under the supervision of Professor Sujit Chaudhry and Professor Safavi Naini. In my bachelor, I have done microwave circuits. In my master thesis, I have done optical Fourier transformation and techniques around Fourier optics. And in my PhD, I have investigated the application of superconductivity in optoelectronics. So I'm receiving questions that what are the main attributes a submitted paper should aspire to have. The papers are going to be focused on superconducting material and their usage in optoelectronics, photonics, and electronics. So the main ingredient of the papers that are going to be submitted in this special issue has to highlight the importance of superconducting structures to do any functionalities in photonics and optoelectronics. I have another questions that when did you first gain an interest in photonics and why? It is a very interesting questions. I think that the first one that I gained interest in photonics specifically was in my bachelor's when I was basically studying electromagnetic fields and waves, and I was fascinated by Maxwell's equations and its abstraction and application. And I was fascinated by the fact that how the entire spectrum of electromagnetic waves can be described by 4 equations, and how we can get all of the phenomena related to optics through these 4 equations. So that was my main fascination of photonics. But later, during my master's work, I got interest in the experimental work around photonics, especially holography. I was fascinated by holography, and I was trying to actually make a hologram in my master thesis. Of course, that it's a quite hard, challenging work, but it was my first real challenge with photonics, and I kept my interest through the photonics during my PhD studies. And since I was also very interested in superconductivity, I was trying to combine these 2 fields together during my PhD thesis. So I have a question: do you have any advice for students today interested in pursuing a career in photonics? So I believe photonics is a very general area. It is a quite broad area now. Anything related to generation, detection, control, processing, and propagation of light is going to be considered as photonics. So my main advice to students that are interested in photonics is to study different areas in photonics, all the way from optical communication, biophotonics, solid state, related photonics, or quantum optics, to find which area is the best for them, and which area that they are interested to work in. And after that, focusing on their study, I think that that's the most important thing. So I have a question that what kind of devices which are near to build now relevant to photoelectronics? Okay, so this is a pretty general question, so I think that I should focus more on devices that are using superconducting materials. So we are seeing a large number of superconducting devices that can be useful in photonics. One of the most important one, which I am also working on it, is superconducting single photon detectors. Superconductors, they do have a much lower energy band gap from semiconductors. So their band gap is in milli-electron volt regime. So this means that the photons with energies that are greater than milli-electron volt they can basically generate some kind of photocurrent in superconductors. So this is why superconductivity can provide a sensitive platform for detection. So over the last 15 years, we see a lot of interesting devices, especially on the detector side, that are quite sensitive to even a single photon. So my answer to this question is that we have single photon detectors that are made now by superconducting materials. So I have the question that what are the important technological challenges to be solved in the field of superconducting, quantum electronics, and photonics? It's an excellent question. So there are a lot of important technological challenges. One of the main challenge of using superconducting materials are cryogenics. So these materials are working at extremely low temperatures, which photonics engineer they don't use to do that, but through the various technologies available nowadays, you can do any kind of optoelectronic and photonics experiment at low temperatures. So I'm talking about like 77 Kelvin temperatures or 4 Kelvin temperatures, and even some of the detectors that are working at 100 millikelvin. So one of the main challenges, technological challenges, are to integrate the cryogenic part with photonics platform. And the other thing is that how we can inject light and how we can collect light from superconducting structures are other challenges. And but these challenges are trying to be addressed in different groups, including my own group. We have another question: why should a professional submit a manuscript to JSTQE rather than another QE journal? So the Journal of Selected Topics in Quantum Electronics is trying to address different disciplines in one issue. In one issue. So saying that each JSTQE issue is devoted to one special issue, and which means that they try to document all the recent progress and the state-of-the-art technologies related to just one area of the research. This means that at the end the JSTQE special issue has more visibility to other audiences, and it's more focused on one special area. But Journal of Quantum Electronics is accepting regularly, papers in different, disciplines that are under the umbrella of the quantum electronics. So I should say that if you have a specific paper that you can find a special issue on it in JSTQE, it is better that you submit that paper to the special issue. But if you could not find or the timeline doesn't suit your plans, you can actually send it out to Journal of Quantum Electronics. I'm receiving another interesting questions that what recent advances in the field are especially exciting or noteworthy. Actually, to me, this superconducting quantum electronics and photonics area is quite interesting and quite exciting. And the excitement comes from the heavy research that is going on making quantum information processors, or what do we call it as structures for qubits. Qubit stands for quantum bit. Superconducting structures, they offer an excellent platform to make quantum states on the circuit. And the This means that a lot of interesting and leading edge progress have been made by researchers in the forefront of quantum information devices and circuits. So we see that there are different schemes to make quantum information processors out of superconducting devices, mainly based on Josephson junctions, like charge qubits, phase qubits, and transmons. So at the same time, you can use these Josephson junctions to act as two-level quantum systems to study the interaction of electromagnetic field with two-level system, which is known as cavity quantum electrodynamics. And because these are based on superconducting circuits, so we call them a circuit cavity quantum electrodynamics. So on the quantum electronics part, we are very excited to actually receive papers, and we do have some invited papers that they address the recent progress in making those structures. And on the quantum photonics part, superconducting single photon detectors are the forefront of the technology in superconducting photonics. We are excited to have some very interesting invited papers to address the recent progress in superconducting nanowire single photon detectors. At the same time, recently some of the researchers talk about making single and entangled photon sources based on hybrid superconductor semiconductor structures, which are very exciting, and hopefully we are going to have some papers around that in our special issue. We have another question: when is the call for paper deadline? So the deadline is June 1st, so in a month. And the hard copy publication is scheduled for March-April of 2015. So we have another questions. How and when did you first get involved with IEEE Photonics? And do you enjoy volunteering? Actually, I became the member of the IEEE in 1999, and I started to get involved with IEEE Photonics Society in 2000 by participating in various conferences that is sponsored by IEEE Photonics Society. And I started to actually get involved with the review process in various journals in Photonics Society. And of course, I do enjoy volunteering for IEEE Photonics Society, especially by reviewing various papers, and I'm quite excited about this special issue as well. We have another excellent question. What are the hot topics in the field of superconducting, quantum electronics, and photonics? Actually, partially I addressed this question, but maybe I should highlight again that using Josephson junctions as two-level quantum systems, they provide a very interesting platform for making qubits, which are envisioned to be the main engine of the next generation of computation. So the hot topic, I should say, is the superconducting quantum circuits and circuit cavity quantum electrodynamics using superconducting materials. This is certainly the first hot topic in superconducting quantum electronics. And in the field of superconducting quantum photonics, I have to say that's the single photon detector using superconducting nanowires is definitely the hot topic in in this area. I have another question. Any advice for students and young professionals on how they can get involved as an editor? That's a very interesting question. Definitely, if you want to get involved as an editor in any journal in IEEE, I think that you should go through the certain steps. So definitely starting to participate in various conferences and trying to form special sessions or forming special workshops in various conferences, and more importantly let the IEEE people to know you and talk to them, and trying to go step by step through the various procedures in the in IEEE. But I believe that there is no specific formula that how we can have anyone involved as an editor in IEEE. The questions are coming into the menu. What is the time to publication of JSTQE, and how quickly are papers reviewed? That's an excellent question. The review process in IEEE is a very rigid process, so we try to have at least 4 people to review any paper, and depending on the subject, depending on the length of the paper, and depending of course the time that the reviewer assign, that varies, but we try our best to do everything in a timely fashion and as quickly as possible. As you can see, for example, our submission deadline is June 1st, 2014, and the hard copy publication is going to appear in March, April 2015. But we might have the soft copy of the accepted papers much sooner in that available in IEEE website. Usually the minimum time for any review is around a month or 45 days, and hopefully less than 5-6 months, as I said, depending on the length of the paper and the reviewer's response. Basically, this is the responsibility of the primary guest editor and the guest editors, that all the papers are going to be reviewed in a timely fashion and as soon as possible. So we make sure that all the papers can be reviewed as quickly as possible for this special issue. Next question: what qualities as a guest editor do you look for in an accepted paper? That's a very good question, and at the same time very tricky question. Actually, the papers in the Journal of Selected Topics in Quantum Electronics are going to be based on invited papers and contributed papers. So invited papers are going to be invited by primary guest editor and guest editors, and the contributed papers should address the unpublished results as well as leading edge results. So we would like to highlight the most recent contributions in the field, and of course we would like to have the highest quality possible contributed papers. So if you have any results that you haven't published anywhere else, and you think that is in the realm of the special issue call, so you can actually submit that by July 1st. Okay, so what is the impact factor of JSTQE? So actually, I think that the impact factor is around 3.5, if I'm not mistaken. But definitely, I think that the impact factor is just a number, and I know that JSTQE possesses a high value of the impact factor between various IEEE journals. Where can we find JSTQE online? So if you go to IEEE Explorer, and in IEEE Explorer website, so you can actually find in journals under the IEEE Photonics Society. So by finding the JSTQE online, also you have the option of going directly to IEEE Photonics Society, and after that, if you are a member, you can actually browse within different papers. But if you are not a member, you can see the different volumes and the title of each special issue in the Journal of Selected Topics in Quantum Electronics. What is considered an invited paper? So the invited paper is going to be invited by primary guest editor and guest editors. So we are considering high caliber experts in each field, and we invite them to send an invited paper. So if anyone wants to submit an invited paper, and they have been already not invited, so they can always send me an email, and we can actually consider having an invited paper based on the results and the caliber of the group. So let me see. Okay, so the impact factor of the JSTQE is 4.078. So one of the audiences sent me this. Thank you very much. So what are the practical applications of entangled photon sources, and what is the current status? That's an excellent question. So one of the main application of entangled photon sources are for quantum communication. So if you have entangled photons, you can actually do a measurement on one photon, and knowing the outcome of the measurement of the entangled pair without any measurement. So they can use as the security resource to do quantum communication. So the current status of entangled photon sources, people have made entangled photon sources out of nonlinear optical materials, as well as quantum dots. And one of the main and recent advancement in the field is using superconducting lead on artificial atoms like quantum dot nanowires. And the natural entanglement of the electrons in superconductivity can be transferred to entanglement of the photons, and can be used as a generation of entangled photon sources. So how many pages is in a contributed paper? So the maximum page for contributed papers are 8 pages. And of course, external extra pages is going to be charged based on the IEEE policy, but invited papers are going to be 12 pages long. And when I say 8 pages or 12 pages, this is based on the double column standard for all of the IEEE papers. I don't see any more questions are coming, so I would like to again highlight the special issue call on superconducting quantum electronics and photonics on Journal of Selected Topics in Quantum Electronics. And the submission deadline is June 1st, 2014. The hard copy publication is scheduled for April 2015. And we're trying to solicit papers on the technology of superconducting quantum electronics, quantum photonics, and optoelectronics. So I see another question. What would constitute a truly disruptive breakthrough in the area of superconducting quantum electronics and photonics? It's a very interesting question. Actually, a true disruptive breakthrough is to integrate different qubits in one circuit. As you know, our usual computers are working based on integrated circuits, and in each integrated circuit, millions of transistors are working coherently to produce and process the data for us. For a number of qubits, if we can actually go around 20 qubits, we can actually start doing a meaningful and super powerful computation. So the real breakthrough is going to show that how we can integrate 20 superconducting qubits into a single chip, and if they are working together, and if we can manipulate the quantum information around them and process the information, that is going to be a truly disruptive technology. In the realm of quantum photonics, the integration of single photon sources and tangled photon sources, single photon detectors, passive waveguides, and all of the passive photonic circuitry together in order to create a truly integrated quantum photonic processor is also going to be disruptive breakthrough in the field. Why? Because now we can make a chip that is able to generate, detect, and process single photons on a chip, and we can make transceivers, for example, the chips that they can transmit photons or receive photons and process photons. That is very applicable in quantum communications. In order to wrap up the discussions, so the call for the JSTQE superconducting quantum electronics and photonics deadline is going to be on June 1st, 2014, is exactly in 1 month. And as I mentioned several times, the hard copy publication is going to be scheduled for April 2015. And if you have any results in the related area of superconducting quantum electronics or superconducting quantum photonics, if you send this to this special issue, is going to be documented amongst the other contributed and invited papers in one issue, which is quite important. And when the special issue appears, you can actually find various papers in a focused topic, which is going to cover all different parts of this area, from device physics, simulation, modeling, experimental characterization, and system integration together. And I would like to encourage all of the researchers in the field to take a look at this special call, and hopefully we are going to have a wonderful special issue by next year. So if there is no any questions, I would like to thank everyone to tune in into Ustream, and I would like to thank Chin Tan Lutz, the editorial from the editorial office of the Journal of Selected Topics in Quantum Electronics, and Lauren Mix from IEEE